I hope everyone is doing well. So welcome to today's video. In this video we'll be discussing on how you can improve your application's load performance. So this was a session that I did in one of the recent front-end sessions that happened here in Dubai, and I thought of sharing this video with you all so that anybody who is looking into improving their application load performance can benefit from it. Alright, so let's get started. So this is me, I'm Joseph, as you might know. I'm author of 2 books, and these books were written back in 2013 with Pact Publishers, and these books are mostly on mobile debugging and mobile application development. I'm a huge enthusiast about web standards, Jamstack, JavaScript, performance and scalability of applications. So you can find more about me on my website. So what we'll be learning in this session? So first of all, we'll discuss why performance matter. We will take up a small demo application. We'll audit it, fix some issues. We'll also do lots of hands-on, learn concepts, and improve our application's performance score. So this session is more about hands-on and less about slides and docs. So application loading performance. So this is a high-level diagram of your application's life cycle. So this is your server, and once you download your application or basically request your application from your server, the resources are getting downloaded into the browser. So this is the application loading stage, and then the application actually runs inside your browser. So our main focus of this video is the application loading performance. So why performance matters? So according to a Google study, it was found that sites loading within 5 seconds had 70% longer sessions, 35% lower bounce rates, and 25% higher ad viewability than sites taking nearly 4 times longer at 19 seconds. So as you can make out, sites that load faster, so there will be more user retention and more people will be visiting your site, they will be seeing your ads, and in a way you will have more revenue. In fact, Google actually uses application performance and loading performance as one of its ranking factors in Google search. So you can read more about this study here in this link. So indirectly, performance is actually money, and that is why performance matters a lot. So how do you tackle performance? So you first audit your site. So we'll be using the lighthouse tool from the Chrome developer tools. Learn, practice and fix, because some concepts might be new to you, so you'll have to learn and practice, fix them on your local host, fix them on your staging server, and then push that into production. You also need to keep an eye on your performance fixes and anything. So any big fixes that go with a particular pull request or a commit might break the performance. So you'll have to keep an eye from time to time, and then continue the cycle. Alright, so let's focus or jump to our demo. I have a demo application. So this is my demo application here. It's a simple single page application and has 3 routes. So this is the home page. I can go to a details page, and then I can go to an edit page. As I said, this is a client-side application and it completely renders on the browser side. This application is built using React, and of course I have bootstrapped using Create React App, and also uses Webpack as its building tool. But the techniques that we discuss here are not limited to React or Webpack. In fact, you can use this with any other application frameworks or even a plain vanilla JavaScript application. Alright, so let's focus on the network panel now, and I'll just show you what all are getting downloaded from my server. So right now, as you can see, this application is running on localhost. So I am locally running this application on my computer, and since this is a React application, so I have been using the React development mode to start the application on localhost 3000. Alright, so we did a hard refresh, and this is the network panel. As you can see, these are the resources that got downloaded from my server. So this is the CSS files, few JavaScript, and then a font file and the images. If you notice here, our JavaScript files, they're very big in size. So you can see 7 MB of around JavaScript, 390 kilobytes of JavaScript. So these are huge payload. Alright, so let's go to the audit section and do a performance audit. So this is Lighthouse tool from the Chrome developers tools, which comes built in with your Chrome browser. So you can use this to audit your site. One thing to notice here is that whenever you are doing an auditing, you always run in your incognito mode, because in the normal browser mode, you might have plugins and extensions which might impact your performance score. So before you run an audit, make sure you check this part which says clear storage. So this will clear your application cache, local storage and session storage, and it will simulate your application loading behavior, the first time loading behavior. Also turn on simulated throttling. So what this means is that if I click on here, it takes me to a documentation, and if you come on the top, you can see that it will simulate the mobile loading experience. So these are the details here, so make sure you turn on that. And I'm running my performance audit for a mobile device. Let's click on generate report and see what happens. Let's wait for the results. Alright, so our results are out. As you can see, the score is 0, which is really bad, and the numbers that you see here are really high. So let's look at few of them, what those means. So first, contentful paint is actually the time taken by your application to show the first pixel or the first content. In fact, if you click here, you can see more details, and there are individual documentations by clicking on learn more. Next item is time to interactive. So this is the time that your application takes to become interactive. Basically, after 45.3 seconds, my application is able to take user inputs, for example, a button click or any other event listeners. And then the first CPU idle, which is pretty similar and related to time to interactive. So you can read more details here, which says first CPU idle marks the first time at which the page's main thread is quite enough to handle input. And then the max potential first input delay is the longest running task that was keeping your browser thread busy. So some task was running, most probably it will be a JavaScript task, which was keeping the main thread of the browser busy, and as a result the browser was not able to take user inputs. Let's come towards the bottom and see more results here. So there are some opportunities and diagnostics that has been reported by the tool. And if you come down, you can see that it says minimize main thread work, reduce JavaScript execution time, avoid enormous network payloads. In fact, these are happening because we are downloading a huge chunk of JavaScript to our browser, and the browser was entirely busy executing that JavaScript. In fact, if I go to my performance tab here and turn on fast 3G with 4x slowdown throttling and click on start profiling and reload page, we can actually see what happens when your page reloads or loads on your browser. Okay, so as you can see, this huge ocean of yellow color here, so that's what is the time spent in executing the JavaScript inside your browser. So this is huge, and at the bottom you can see the markers here. So this is DOM content loaded, this is first contentful paint, this is your browser's onload event, and the other markers. So your FCP even fired at around 9,000, close to 10,000, so which is like 10 seconds. So it's a huge application load time, and your first content actually showed up after around 10 seconds, which is really bad, and this is what was actually keeping the browser busy. Let's go back to normal mode. Let me clean this up, and let me go to my network panel. As you can see, in fact, in my previous section, I have already discussed the JavaScript that I'm downloading are huge. So you can see 7.2 MB of JavaScript, 390 kilobytes of JavaScript. And one more thing to notice here is that the JavaScript that I'm downloading is not minified. So it's running the actual source code with all the comments and whatever unused imports and all these things are still existing in my application. And that is why all these issues are coming. Let me go back to my audits panel, and let's take care of few issues like reduced JavaScript execution time, main thread work, and enormous network payloads. So the first optimization that we will be doing here is enabling route level code splitting. So this is my application which is opened on my code editor, and this is a React application. So this is my app.js file, and these are the routes that I have. So as you remember, we have home page, details page, and edit page. So let's enable route level code splitting. So let me comment this part and let me enable this part. So this enables route level code splitting. So what does that mean? Let me go back to my slides here and go to code splitting. Okay, so code splitting is basically dividing your full or the total JavaScript bundle into smaller pieces. So if this is your entire application's JavaScript, you break down into smaller pieces. It's not only JavaScript, it can be CSS also. So there can be two types of code splitting. One is route level. Since our application has home, details and edit, so we divide the entire JavaScript application payload into smaller pieces. This is mostly because say your application is huge and you have many more routes than just 3 routes. So why you are downloading all the JavaScript upfront and making your application load slow? Because some of your users might not even reach to the edit page. So why I'm unnecessarily downloading the JavaScript related to edit page upfront? So why not delay it or lazy load it or basically load on demand? So this is the concept of code splitting. And then there is another way of code splitting which actually Webpack automatically does when you run in production mode. We'll quickly go into that. But the idea is, say you have 2 files or 2 modules you are using in your application, and there's a common module that both of these files are using. We split out the common module as a common file or a separate bundle, and then the files become lighter. Also the duplication of these modules are reduced. So let me go back to my application again, and I have already enabled route level code splitting. So this you can do using react.lazy function, which is by default supported, and you can use the import statement. The import statement will enable dynamic load chunking or dynamic download of your JavaScript chunks. And in fact, Webpack also supports something called as magic comments. So you can name your chunks. These are basically the JavaScript chunks. So you can name it as home chunk, you can name it as details chunk, and then edit chunk. So now let me go back to my application and see if this works. So let me clear this. Let's clear the network panel and then just reload my application. So I'm doing a hard reload, so to clear the cache. Let me come back to my section here. In fact, let me go back to JavaScript panel. So these are the JavaScript that is getting downloaded now. As you can see, my home chunk here. So I'm not downloading the entire application up front. So whatever is needed for my first page to show up is being downloaded. So if you see here the home chunk, one thing you might notice is the code is still not minified. We'll soon take care of this. And then these are other chunks which is necessary. So these other chunks will have the React library and other common modules that I'm using, such as so just to deliberately make my application heavy, I'm using Lodash, Moment, and a few node modules or npm packages. So these bundles will contain those libraries. But these are all code splitted by the Webpack bundle. Okay, so let's clear this up and let's go to our details page. So as you can see now, more JavaScript are getting downloaded. So this is the JavaScript that's needed for the details page to show up. Now let's go to edit page. As you can see, more JavaScript is getting downloaded. So we have enabled code splitting, and now let's do an audit and hopefully our score should improve. Let's go to my audits panel and make sure you are already checking these things. Click on this button and let's wait for the report. Alright, so our score is out. If you notice, it has improved a little, but then still there are a lot of optimizations that we have to do. So let me quickly go to my performance tab and see the application load behavior. So you can see the overall time has reduced now, and the huge ocean of JavaScript execution that we had earlier has been reduced. This is because we have enabled code splitting and only lesser JavaScript is getting now downloaded into the browser. In fact, you can notice the FCP and all these markers are being fired much before, so it's around the 2500 milliseconds time, which is close to 2.5 seconds. But then there are further optimizations that we need to do. Let me quickly go back to my normal mode, and if I come to my network panel here, so you can see my home chunk. So first of all, this is not minified, so this is one optimization that we'll do. The other one is we'll talk about tree shaking. So what is tree shaking? So let me quickly go to my slide and talk about tree shaking. So in your application, you'll be using a lot of JavaScript modules and a lot of utility libraries, a lot of other NPM modules, and usually your application will grow. So at some point, your application will have unused imports that are basically you have imported that particular module into your application, but you are not using it. So right now, the application demo that you are seeing is including all these unused imports into its build. So that is why our JavaScript is huge. So with tree shaking, you can actually remove all this unused import. As a result, you'll have lot lesser payload. In fact, Webpack supports this concept of tree shaking, and you can enable this by turning on the production mode in Webpack. So before going into that, let me quickly show you in terms of an example inside the code what is tree shaking. So here I come to my home page JavaScript code. So if you can see here, I am actually having a small utility library which I have written for my custom purpose, and there are sum and multiply functions, and I am importing that from my utility library and then using it here in my application. So this is my sum function, this is my multiply function, and the utility library is here. So this is the sum, this is the multiply, this is divide and modulus operator. If you notice in the home page, I am only using sum and multiply. I'm not using the rest of the two modules. But if I go back to my application here and open up home chunk and look for the sum function, so you can see here I have all the modules being imported into my application. Even though I'm only using two, the other two are also being added to my JavaScript payload. So this is actually increasing my size. So we can take care of this by tree shaking. So let's now go to my Webpack config. So this was a React application, as I have told you before. I have actually ejected it because I am so that I can configure my Webpack config. So back into my Webpack config, I can turn on production mode. So if you search for mode, it's already actually provided by Webpack. You need not do anything. So when you generate a production build, it will run in the production mode. So let's do that. So this will do two things. It will do tree shaking. It will also minify your code and other optimizations that is needed for the production mode. So let's do that. So to generate a production build, run the command npm run build, and let's wait for the build to be generated. So you can see our production build has been generated, and it will create a build folder where it will dump all the files. So if I open this, inside the JS folder you can see all your JS chunks, the JavaScript pieces, and then the CSS that is needed by your application. Now, so this is the build folder. Now you need some kind of a server to run and serve this build folder. So for that I have written a small node express server which will serve my build folder. So this is here. So this is the express static path, and I'm exposing my build folder into the static path. So now I can start my node server. In fact, for that I have a small command that I can use. So I can use the npm serve command. So let me run npm run serve, and this starts my local server at 4040. So let me go back to my application, and instead of 3000 now I'll run at 4040. So the application loads. The code splitting is still there, so you see only the files necessary for the first load, and then dynamically it loads more files. But then the other optimizations has been done. So if you go to my home chunk, you'll see the code has been minified. Also tree shaking has been done now. So if I look for my sum function, and you can see multiply and sum, so you don't see the other modules. So tree shaking is working, and our files are a lot leaner now. So if you go and check, the files are smaller in size, and let's do an audit and see the score. So let's clear this up, and again make sure you have this turned on and click on generate report. So our scores are out, and you can see a huge improvement in our score. Also we are getting closer to the 2-second mark that we are looking for. If I come down, you can see the reports that were there earlier about the huge payload and a lot of JavaScript are gone now. So these are the other optimizations that we need to take care of. So we have successfully reduced our JavaScript payload with code splitting, with tree shaking, and running Webpack in the production mode. So this will take care of minifying, as I said, tree shaking and other optimizations, so that your JavaScript payloads are a lot smaller and leaner. Now let's look at the other optimizations. So this is what we'll be taking up next. So this says eliminate render blocking resources. Let's understand what is render blocking resources. So back to my slides, let's understand what is render blocking. So CSS files are render blocking in nature. In fact, even JavaScript and font files. What that means is that when the browser starts to download your CSS file, it has to first parse it and then execute it before you can see any content on your browser. So till that time your browser is basically blocked and it's freezed, so it cannot do any other action. So that is render blocking. So you will see a blank screen on your browser till the CSS is getting downloaded, parsed and executed. So in fact, if you have a bigger CSS, a lot more CSS and JavaScript, so your browser will take more time to show up content. That is render blocking. Let's go back to my audit report and see what is causing render blocking. So if I open this section, you can see it is reported that these two CSS files are causing render blocking issues. So that means these two CSS files has to be first downloaded and executed before my browser can show up content. So this might impact your first contentful paint. The bigger the CSS, the more time the browser will take to show up content. Let's find more details in the code coverage panel. Inside your browser DevTools, in fact, I can click on Command Shift and P on my Mac and search for coverage, which takes me to code coverage. And let's reload or basically start the instrumentation again. So click on this and it reloads all your files. So you can see, since it was reported our two CSS files, so we'll go to the CSS file, and as you can see the CSS file here. So this is causing the render blocking issue. So you can see the green color and the red color. So the green color is the critical CSS and the red is the non-critical. So let me just minimize this part and show you here. So the critical CSS is the CSS that is executed by your browser on this page. Basically whatever you're seeing now are using these two CSS classes or styles, and the red ones are not being used. Maybe they will be used later. So one technique is to copy paste or basically cut out the CSS from here and put it inline into your index page. So that is known as putting your inline, putting your critical CSS into inline styles, and then preload the rest of the resources, or basically you lazy load the rest of the CSS file. Similarly here for the other CSS file, you can see in fact it's not being used at all. There might be some issue with my browser auditing tool, but in fact I am using custom font. So if I go here into my header section, and this is the H6 element, so I'm using a custom font which is downloaded from Google. So if I click, unclick or check, uncheck, you can see the difference. Let me go back to my coverage panel and click on this. So what we can do is that we can also move this inline. So we can copy from here and totally remove this unnecessary HTTP request and move the entire style inline. So let's do that. So in fact for that I'll go to my index page, which is here inside the public folder. This is the index.html. So this is the call to the custom font that is getting downloaded from Google. So let me comment this part and let's copy this style from here and put it in line. So let me define a style block and specify a CSS and paste it here. Let me indent it so that it looks good. Alright, so I made it in line. Now the other CSS file is here, so let's copy these two parts here. In fact, I'll go to my code because I have to remove from there. So the CSS is here in the index.css file. So I will cut from here, save this file, and then I'll put it as inline. So I can put it here in the same block. Alright, so let's indent this so that it looks good. Okay, so I've saved my file. I can generate a bundle again since we are running in production mode, and then I can start my node server to serve. But then the other optimization that I talked about is lazy loading the other part of the CSS. So that is what is done using web primitives or resource hints. So for that I'll go back to my slide and explain it. Okay, so we have already talked about render blocking resources and how render blocking can cause issues. So to handle that we can use something called as preload and prefetch, which are also known as resource hints or web primitives, to lazy load resources. So this is how it looks. So you have a preload tag and a prefetch tag, which you can specify for your resources. So we'll be looking at prefetch in later part of our video, but for now we'll be focusing on preload. So what preload tells the browser is that download this resource, which is the styles file here. So download this resource as a high priority and put it into your cache once you are downloaded. So once it's there in the cache, it will still not be executed. So it's there in the cache. So once that particular file is referred in the browser, then it immediately loads from the cache. So your resource is basically available to you when you need it. And the good thing about preload is that all this happens asynchronously. So your browser is actually not blocked. So whenever he is downloading a resource which is a preloaded resource, so it can still go and do other things. So in fact, in my next slide, I have the details here. So if you see, this is a typical loading experience. So this is the index.html, which is the first call. So it always gets downloaded onto your browser. Then let's say the browser identifies a preload resource. So it starts to download the preload, and then it also simultaneously keeps on downloading other resources. And then once the preload resources is downloaded, it will put into the cache and make it ready so that it can be used by the browser later. So for that, Webpack supports preloading. So in fact, there is something called as magic comments which you can use. Let me go back to my code. So if I go to my app.js in the code splitting part, so which is here, so you can specify Webpack preload, something like this here inside the magic comments section. Webpack preload true. So this is supported basically from version 4.6.0. So you can enable this, but instead I'll use a plugin which is available to me because the plugin gives me more ability and more flexibility. So for that, let me go back to my config, the Webpack config, which is here, and let me come to my top of my page. So this is my preload plugin, which is here. This is what we'll be using to specify our preload resources. So if I go here, let me uncomment this part, and this plugin will actually preload my initial resources. So all my initial files like the CSS files and other resources which are downloaded initially will now be preloaded. So my browser will download them asynchronously and put it into the cache. So now that we have optimized our application, we can generate a bundle and see. So what we have done is we have taken care of moving the critical CSS inline into the index page and preloading the resources which are needed later in the page, so that my critical rendering path is not blocked, and initially my page can go ahead and, in fact, the browser can go ahead and show my content quickly. So let's do that. Let's generate a production bundle. So we'll go npm run build. Let's wait for the build, and now let's start a node server. Let's clear this all. So let me go back to my normal behavior and let's clear everything. Let's clear the audit section. Let's close this guy and do a hard refresh. Alright, so now I have enabled preloading and moving few styles inline. So let me go back to my elements tab here and click on the head section. So you can see the preloaded resources somewhere here. So if you can see here, this is the CSS file which is getting preloaded, and then few style which we have made inline should be here. So these are the styles that I made inline. So we have prevented our browser from making extra HTTP call to the server, and then we have also preloaded resources. So our score should improve now. Let's do an audit and find out. So our score is out, and as you can see, it has improved over the previous score. And also, if you notice, we are getting close to the 2-second mark and our green color has started appearing. That means we are doing good. So if I come down now, so let's look at our next optimization. So it says ensure text remains visible during web font load. So this is something to do with the Google font that we are downloading. So what this means is that when my browser is actually downloading the font, or in fact the CSS which uses this font, so till the time it is downloading, and then it is discovering the font file. After that, it will make another call to the server for the font file. Until that time, the content that is actually using that particular font is blank. So it basically cannot render because it uses the custom font. So we can in fact go back to my code and I can explain in that. So for that, I'll go to my index page, and if you notice the styles here, so this is what we copied from the CSS file which was used for the custom Google font. So if you see here, this is the reference to the font file that is getting downloaded from the server. So you can see here the two font files. So why this issue is coming is that first of all, the browser will make a request for my index page. So the server delivers the index page and my browser starts to render the index page. And then it discovers the CSS here, the CSS part. So once it starts to parse the CSS file, then it discovers the font file. and then again makes a request to the server for the font file, and then starts downloading the font file. So all this thing happens, and there's a lot of round trip that's happening, and the browser is actually waiting for the font file to get downloaded, and then it can go ahead and show the content, since I'm using this custom font. So we can optimize this again by using the concept of preload. So we can preload our font file and keep it in the cache, so that once the browser parses this CSS file, and hopefully those two font files will already be there. So we'll save some extra millisecond. So for that, I will just uncomment this part. So let me just enable this and comment this part out. Sorry about that. Okay, so here I'm using the preload tag again, but as you can see, I'm using it for the font, and then I'm putting the path of the font file. And then these are other parameters which are necessary, so you can always browse and then learn about them. And the other small change that we need to do is enable font display swap in my CSS. So for that, I'll go here and put this block of code. So what this tells the browser is that till the time my custom font is downloaded and it is available for you, go ahead and use the system default font, the default font in the browser. So this should solve our problem that we had seen earlier, which was reported by our audits. So the two optimization that we did was we enabled the font display swap, and we also enabled preloading of our font files. Now let's generate a bundle again, and then start our node server. Let's go back to my application and audit it again. So our score is out, and if you notice, the score has gone down a little. So let's not worry about that, but hopefully our issue that was reported with the fonts is solved now. So in fact, you can go into the past audit section here, click on it, and then at the bottom you can see that all text remains visible during web font launch. So our test has passed. Now let's move ahead on to other optimizations that we can do. So the next one that we'll be taking care of now is enable text compression. So what this says is that, so we'll have to compress our text files, which are mostly JavaScript files, CSS files, it can be JSON files. So in fact, if you go back to the network panel and just do a hard reload. So let me go to my JavaScript panel here, and in fact you can see that we haven't enabled compression. So whatever the size of the file is, the similar size or the actual size is getting downloaded to the browser, and our overall download size is higher. So let's enable text compression, and then we can solve this problem. So for that, I'll go to my server.js file, and I'll enable the compression module. So this is an npm module which will enable gZIP compression in your application. So for that, I'll just uncomment this line. So this enables compression as a middleware, and for every request which comes to the server, it will compress the static files, basically the request for the static files, so it will compress them and send it over to the browser. So let's start the node server again. We don't need a build now because it's a change on the server side. And let's go back to my network panel, do a hard refresh again, and now as you can see, your total size was 127 kilobytes, but your download size is 41.9 kilobytes, and also your overall download size has reduced. So what this will do is that it will reduce your overall payload, and your application will load faster, and your time to interactive will become lesser. So let's go to the audit section and do an audit again. There we go. So our score have improved significantly over the last one, and all our major pointers are now started to show up as green. So let's move on to the next optimization that we have here. So it says preconnect to required origins. So if I open this guy here, so it says that from my application, I'm actually connecting to a third-party domain. So it's telling me to pre-connect to that domain so that we can save some extra time in DNS mapping and DNS connection, TLS handshakes and all these things. So in fact, if I go to my network panel here, if I go to my image panel, and all these avatar files that you see here, the image files, are getting downloaded from the S3 bucket. So it's a third-party service that I'm using, and it's getting downloaded from the S3 bucket. So we can enable this in our index page again. So we have something called as preconnect. Let me uncomment this part and then explain to you. Along with preload and prefetch, we also have something called as preconnect. So this is a preconnect tag. So this basically informs the browser that as soon as you see a particular domain here, so connect to that particular DNS, do the DNS mapping, DNS handshake, do the TLS handshake and the TCP connection, so that once these domains are being used in your application, so you already have the DNS mapping and the handshakes done, so you'll save some extra time in that. So let's save the file, and now we'll do a generate a build again because we have changed our index page. Now let's start the node server and go to the audit section, clear this and run an audit again. So our score has improved a little. From 94 it went up to 96, and if you see here, the diagnostic that was reported earlier is not there. Alright, so let's move on to the next one, which says serve static assets with an efficient cache policy. So what is caching? So if I come to my network panel here and just do a hard reload, so the first call that goes to the server downloads all your resources. And if I go to my JS, in fact I'll go to my all panel and you can see all these resources getting downloaded. Now let's refresh the browser again. I'll not do a hard refresh, so just now do a normal reload and see the network panel again. So as you can see here, the files that are here are not loading from my cache. In fact, it is again hitting the original server and downloading from the server. So this can be a performance problem because the static files that we have here, like the CSS JavaScript, hasn't changed between the two calls. So why we are downloading again from the server? In fact, we can enable caching in the browser and the browser can cache them, so that next time you reload the application or refresh the page, it loads from the cache. So let's enable caching by modifying my server.js file. So I'll come to this section here, and this is where I exposed my static path, and this is where I can enable caching. So these are again the syntax from Express.js server, so you can learn more about them. But this is the response header that enables caching. So it's also known as cache control TTL header, and I have enabled caching for 1 year. So 1 year is the maximum that is recommended as per the standard. So you can set for 24 hours, whatever is your need. So I've enabled it for 1 year. So the value that you see here is in seconds. So if you convert 1 year into seconds, that's the value. So let's save this file and start my server again. Okay, so let's go back to my application and now let's do a hard refresh. And the resources are getting downloaded here. Let's do a normal refresh now. And now as you can see, it's loading from my cache. So this does two things actually. So first of all, it is not hitting my original server, so there's less load on my original server. Next, the cache, these files are actually getting downloaded from the cache the next time when I reload. So it's much faster than making a round trip to the server. And if I click on any of these files, you can see the value here. So it says cache control public max age 31536,000. So in fact, I have a separate video on caching and how to enable caching and all the details related to caching, so you can catch them out on my YouTube channel. And here the value of public says that you can cache this file both on the browser and the CDN. So in fact, if you're using a CDN in front of your server, even the CDN will cache it. Let's go back to the audits panel and run an audit. So let me clear this, and so our report is out now, and as you can see, the issue that was mentioned earlier is not there. So it should be there in the past audit because we have enabled long-term caching now, and our files are getting cached on the browser. So you can see it here. Alright, so we have taken care of all our issues, and we have been successful to do that. And let's quickly move on to the other section of my session. So we'll talk about prefetching now. So we briefly touched about prefetching earlier. Let me explain you in details about prefetching. So let's clear this up and go to my network panel and enable a slow 3G reload. So it simulates a slow 3G network. Let's go and do a hard reload. So now the application will take some time to load because it's running on a slow network. So you can see a loading message here, which is because it's downloading my resources and then rendering my content. So as you can see now, it has rendered the content. Let me clear this up. Since we have enabled code splitting, so let's go to my details page and you will see the similar loading experience when I navigate to details. So you can see a loading message here, it's downloading the files and now the content shows up. If I go to my edits, similar behavior, so you see the loading message and then the files gets downloaded and then renders the content. So you can see a significant performance impact in terms of a white screen or a loading screen in between page navigations. So that's where prefetch can help us. So let's understand prefetch more from my slides. So I'll go to my next slide and this is prefetch. So if you have multiple pages in your application, such as page 1, page 2 and page 3, so whenever you are downloading page 1 or maybe downloading your initial resources, you can prefetch download the resources for the next page so that these resources are available to you in the prefetch cache, which is a cache in the browser, and then whenever you navigate to the next page, it immediately loads from the cache. So this is the normal behavior. So say in the normal behavior you download page 1 and then when you navigate it starts to download the resource for the next page. But when you prefetch along with the download for your page 1, you can prefetch the resources for the next page. Again, as I said earlier, preload and prefetch are asynchronous in nature. They do not block your browser, and when you are doing a prefetch download, the browser will actually download the resources whenever it's idle and whenever it has bandwidth. So it always starts with the preload first. So preload are higher priority and then it goes to prefetch. So whenever the browser is idle, basically whenever it's not doing any other task and if it has bandwidth, so it will start to download the prefetch resources. So we can enable prefetching by going back to my application. So for that I'll come back to app.js file and I'll copy this part and just put it here. Okay, so this is another magic comment that Webpack gives me, and I can enable prefetch by just specifying Webpack prefetch true. And here as for an example, I have enabled prefetching on my details page. I have left my edit page as it is. So let's see the behavior. So for that I'll generate a build. And now let's start the node server. Let's go back to my application. And first of all, let's go back to online and do a hard reload. And since I'm already there in the all section, so as you can see here, the prefetch resource for the details page is getting downloaded here. So this will be downloaded by the browser and put it into the prefetch cache. So it will still not execute this JavaScript. So this JavaScript is still not executed. It's only there in the cache. But as we keep navigating to our pages, it will get downloaded. Basically, it will put it into the browser head section and then it will start to execute the JavaScript. So let's go back to the slow 3G mode and simulate a page transition. So now let's go to my details page. As you can see, it loads instantly. So the loading time was less, little less here. In fact, a lot less. Let's go to edit page now. So you can see here the loading screen. So here the loading experience or the loading time is much more because we haven't enabled prefetch. So this is how prefetching can help you improve your page navigation or page transition time. Alright, so I hope you found these techniques useful, and will definitely give preload, prefetch and preconnect a try. These resource hints or web primitives can help improve your application performance a lot. So let's move on to the next section of our video, and for that I'll go back to my slide and what's next. So we'll be turning on Brotli compression now. So Brotli is another compression algorithm which can be used instead of gZIP. So in fact I'm using Brotli in our production app, and we have seen an improvement of 20 to 25%. So Brotli can compress your static files more than gZIP. Let's enable Brotli into our application. So for that I'll go back to my Webpack config and come to the top, and as you can see I have two plugins here. These are Webpack plugins already available. So the compression plugin is used for gZIP and the Brotli plugin is used for Brotli. So let's enable this. For now I had commented it out. Let's uncomment them and enable this. Now let's generate a build again, and so you'll see what happens. Alright, our build is generated. Now let's quickly see what's inside the build folder. So if I go into my JS section now, so you can see gZIP and BR files being generated. So these are file extensions for the gZIP compressed file and then the Brotli compressed file. So both of these are created since we are using the two plugins, and these are put it into my build folder. Now whenever my browser makes a request to my server, the server can serve based on the accept encoding header tag, and that is what we will do next. So let me go back to my server.js file, comment this part here since this was the default gZIP compression, comment this part as well, and uncomment this part, and let's uncomment this part. So what this does is that, so I'm using an external npm module express static gZIP, which handles the browser request, and based on the accept encoding header parameter, so it can be Brotli or gZIP, so it will serve the correct file. So if the browser is requesting for Brotli, then it will serve the Brotli file. If the server does not support, if the browser does not support Brotli and it requests for gZIP by default, so it will serve the gZIP file. So all the settings are here. You can find more details in the documentation of this particular module. So let me save the server.js file and start my server again. And let me go back to my application, clear this up, and just do a hard reload. And as you can see now, Brotli has been enabled. So the BR stands for Brotli, and if you notice here, the sizes that are getting downloaded over the network will be much lesser. Now since I'm running on localhost, this might not be a significant change, but once you put your application into production, your application will load faster, your time to interactive will become smaller. So we have been able to enable Brotli successfully, and this is another optimization which you can take care. Brotli is widely supported by all major browsers, and it has higher compression than gZIP, so you can definitely use Brotli on production. Let's move on to the next section and see what's in store. Alright, so the next section talks about monitoring your performance, and for that I have an article which talks about how you can incorporate lighthouse tests into your pull requests. So if I click on the image and let the article open up, so this whole article has the entire details on how you can incorporate lighthouse with your pull requests, so that every time somebody commits a code or makes a pull request and that pull request gets merged to your branch, so you can actually run lighthouse tests and do a performance audit. So I'll not go into the details of this, you can read the article, it has the full details. And just to give an introduction, I'm using Circle CI, which is a CI/CD pipeline tool. It's free for open source projects, so you can use it. So the CI/CD pipeline will actually run your tests and then compare your scores. So using Jest, which is an open source testing framework. So this is how it looks. So these are your scores, and then finally you can use Jest to compare your performance score. So if your score is less than a particular benchmark that you have set, then your CI/CD tool will fail your test, and you can actually see that in your pull request. So in fact, let me show you that. So I'll quickly go to my GitHub repo, and I have a project where I'm using this, and for that I'll go to my repo. I don't remember. Yeah, this is the repo. So let me go here and let me go to my pull requests, and let me open this. So this is where the test is running, and Circle CI, I'm using Circle CI. So since the test passed actually, so it has a pass result, but you can also fail your results based on some benchmarks. Then this is how it will look, and your PR will also say that the tests have failed. In that case, you can take a look at your PR and make improvements and then merge it. So the next one is, so these are the two videos that I was talking about briefly earlier. So you can go to my YouTube channel and check out about caching. And I also have another video about gZIP compression. So it has all the details that you might need. Alright, let's move on to the next slide. And this is a server architecture. It's a very high level architecture that can be used for improving performance. because till now we have talked about how you can improve performance when the application is loading into your browser, but then performance also depends on how your server behaves. So if you're using a reverse proxy, if you're using clusters, and then if you're using CDN, so all these things will matter into your overall application performance behavior. So I'll not go into the details, this is because this is mostly a front-end session. The entire server architecture is a broad topic and it's a subject in itself. So thank you so much for sticking with me in this video. I hope you enjoyed this video and have learned few techniques how you can improve your application load performance. So always use the audit tool that comes with your Chrome browser, do an audit, check out the report, learn the concepts, fix them, and then push it into production. Thank you so much guys. If you have any questions, do leave them in the comments box and I'll get back. You can also browse my website and find out more about front-end stuff, JavaScript, web standards, and much more. And also you can connect with me on my LinkedIn. If you like this video, share it and also subscribe for more.